Open System Interconnection (OSI) model. OSI stands for Open System Interconnection, and it has 7 layers architecture, with each layer having specific functionality to perform. These layers work collaboratively to transmit data packets from one networking device to another networking device across the network. It is a referential model that set a standard to let us understand how a communication takes place between devices in a network, and the process is divided into various layers to framework its functions in each layer. This framework helps us to design and troubleshoot a network if problems arise. There are 7 layers in OSI model, and when two devices take part in a communication, then it starts from top layer and comes down to the bottom layer, and again it moves the journey from the bottom layer and reaches to the top layer to complete the single communication between the sender and receiver. Therefore, when the sender sends data packet, then that will travel from the top application layer, presentation layer, session layer, transport layer, network layer, and data link layer, and at last to the physical layer. The data packet will now travel through the physical layer and reaches the receiver end, and then from the physical layer it will move to data link layer, network layer, transport layer, session layer, presentation layer, and finally it will reach to the application layer of the receiver end, where the receiver will get the information in the form of an application. 7 layers architecture of OSI model. Application layer. 7th layer. This is the topmost layer of OSI model. The network applications implements the application layer. These applications produce the data, which are there for being transferred across the network. This layer often serves as a window interface for the application services to access the network, and as well as to display the received information to the end user. Applications that work in application layer are browser messenger interface, so all applications appear on the desktop screen. Therefore, application layer is also known as desktop layer. Protocols work in application layer are HTTP, FTP, SMTP, and there are many more. Presentation layer. This is the 6th layer. The presentation layer is also known as the translation layer, because when the sender sends information, then the data is extracted here from the application layer, and then it is manipulated to the required format for transmitting over the internet network. But if we discuss about the receiver end, then it just reverses the process and pass the data to the application layer. Encryption and decryption. Data are translated to a secure form or code, which is known as encryption of the data, and encrypted data is also known as the ciphertext, and the encrypted data is further needed to be decrypted as when requirement arises at the receiver end, that is converting the encrypted data into plain text. The most vital thing to remember is that for the encryption and decryption process, a key value is used. compression. To minimize the size of any data, compression is used by the presentation layer to reduce the number of bits that needed to be transmitted across the network. But again, the compressed data is further decompressed at the receiver end. Session layer. Layer 5. Session layer, by the name itself, is responsible for the establishment of connection and maintenance of the session through authentication along with ensuring the security. Therefore, it establishes connection between the sender and the receiver before sending the actual data packet and ensure authentication to ensure security between the intended communicators. The functions of the session layer are session establishment, maintenance of current session, termination of session. Let us understand synchronization. Through the synchronization process, data loss is avoided by adding checkpoints, which are considered synchronization points, into the data, and these synchronization points help to identify the error so that the data can be resynchronized properly as the end of the message are not cut prematurely. Now let us discuss dialog controller. Two systems are allowed to start communication with each other in half duplex or full duplex by the session layer. We should remember one thing, that all these layers below, including the session layer, are integrated as a single layer in the TCP/IP model as application layer. Therefore, implementation of these three layers is done by the network application layer itself. Let us consider a situation where a user wants to send a message through any given message application running in the system browser, and that message application will act here as the application layer, which provides an interface to the user for creating the data. This message or the data is compressed or encrypted in case of any secure data, and then it is converted into bits, that is zeros and ones, so that it can be transmitted across the physical network. Transport layer. Layer 4. The transport layer lies above the network layer, and it takes services from the network layer and provides services to the application layer. It is also called the heart of the OSI model architecture because it separates the top three software layers and the bottom three hardware layers. Transport layer is responsible for the end-to-end delivery of the complete message, and the data in the transport layer is referred as the segments. Therefore, the transport layer provides the acknowledgement of the successful data transmission and also retransmission of same data in case if an error is identified. It uses protocols such as TCP and UDP. We will go into discussion of these topics in other lectures. This layer will convert the pure data from the sender and add the transport header to it. That is the port number for identification purpose, and convert the same into the protocol data to transmit the same over the network. If we discuss about the receiver side, then it just performs the reverse operation. At the sender side, transport layer receives the formatted data from the upper layer, that is session layer, and then it performs segmentation as well as implements flow and error control to ensure proper data transmission. After that, it adds the source and destination port numbers in its header and then forwards the segmented data to the lower layer, that is network layer of OSI model. One most important thing to note that the sender needs to know the specific port number associated with the receiver end application. Generally, these destination port numbers are configured by default because all applications are having their default port numbers. Let us assume that a web application makes a request to a web browser. Then it uses port number 80 because this is the default port assigned to all web applications. At the receiver side, if we discuss about the receiver side, then after receiving data, the transport layer reads the port number from its header and forwards the data to the respective application. At the receiving end, it performs sequencing of the segmented data and reassembling of the same data. The functions of the transport layer are segmentation and reassembling. The transport layer accepts the message from the session layer and breaks the long message into smaller units so that it can be easily transmitted over the network. Now each of the segments is provided with a header associated with it and containing information of sequential order of the full message. The transport layer at the receiving end reassembles the complete message through proper sequencing of those broken smaller units. Service point addressing. The message has to be delivered in correct process to the intended receiver. That is why the header of the transport layer includes a type of address called port address or service point address. Therefore, through this address, the transport layer makes sure that the message is delivered in the correct process and to the exact receiver. The service provided by the transport layer. Connection oriented service. Let us discuss about connection oriented service. It has three phases to process that includes the following: connection establishment, data transfer, termination or disconnection. In connection-oriented transmission, the source device receives an acknowledgement from the receiving device that the packet or the packets have been received successfully by the destination, that is receiving end. That is why this type of transmission is reliable and secure. Connectionless service is much faster way of communication compared to connection-oriented service, because it is one-way phase process and includes single-way transfer without receiving acknowledgement of the received packet or packets from the receiver. That is why it is less secure and reliable. Network layer. This is layer 3. The network layer lies just above data link layer, and it works for the transmission of data from one host to the another host located in different network, along with taking care of packet routing. The network layer selects the shortest path to transmit data packet through the router, covering short distance in the way of destination. Therefore, the sender and receiver's IP addresses are placed in the header of the packets by the network layer. The functions of the network layer are routing. Let us understand routing. It is the most important function that is performed by the network layer of OSI model, and that is to determine the best suitable route from the source device to the destination device. Another function of network layer is logical addressing. The network layer defines an addressing technique in order to identify each device on the internet uniquely. The sender and receiver's IP addresses are placed in the header of the packets by the network layer because an address distinguishes each device uniquely and universally over the global network. The protocol used is IP, that is Internet Protocol, to convert the segment into the packet by adding logical IP address of the destination device to the packet before sending it to the data link layer. If we discuss about the receiver side, then it just perform the reverse operation. Router is one type of hardware device that works at this layer, and it understands the logical division of IP addresses, and it communicates among different networking setup. Data link layer. This is layer 2. The data link layer is second last layer of OSI model architecture. It further divides the packet into frames, and it is responsible for the node-to-node delivery of the message. This layer makes sure that the data transfer is error-free from one node to another node over the physical layer. Therefore, when a packet arrives in a network, it is the responsibility of the data link layer to transmit that packet to the host using its MAC addresses. MAC address is the physical address which is unique identity of device, and MAC address of two or more devices can never be same. That is why MAC identity is added to the frame, and that frame is received by the physical layer. But if we discuss about receiver end, then the operation just take reversal process from bottom to top. Data link layer is divided into two sub layers. Logical link control, that is LLC. LLC controls the synchronization, flow control and error checking function of the data link layer. Media access control, that is MAC. MAC is responsible for moving data packets from one network interface card to another network interface card in a network across a shared transmission media. Functions of the data link layer are framing. Framing is a mechanism where a sender transmits a set of meaningful bits to the receiver, and that can be accomplished by attaching special bit pattern to the beginning and end of the frame. Another function is physical addressing. The data link layer adds physical address, that is the MAC address of the sender and the receiver in the header of each frame, just after completing the frame creation process. Another function of data link layer is error control. The data link layer detect and retransmit damaged and lost frame. Those are changed during transmission across the network, and in this way the data link layer provides the mechanism of error control. Flow control. It is responsible for maintaining consistency of data between both sending and receiving end. Otherwise, the data may found to be corrupted. Thus, before receiving the acknowledgement, flow control coordinate the amount of data that can be sent. Another important function of data link layer is access control. When multiple devices use a single communication channel, then the MAC sub-layer of the data link layer determines the device controlling schedule over the channel at a given time. That is, when one device has control over channel, another device have to wait till their turns come. In this way, access control is one of the vital operations which are processed by the data link layer. Some of the networking devices which work on the data link layer of OSI model are switch, NIC and bridge. Physical layer. This is known as layer 1. The lowermost layer of the OSI model is known as physical layer, and this layer plays a vital role to connect all networking devices physically across the network, because physical layer is responsible for the actual physical connection between the devices. This layer contains information in the form of bits. Therefore, it is responsible for transmitting individual bit from one node to another node, and so on. At the time of receiving signal over the network, physical layer first gets the signal, and then it converts the signal into zeros and ones, that is digital information for understanding of computers, and send those to data link layer. The functions of the physical layer are bit synchronization. By providing a clock, the physical layer provides the synchronization of the bits, and by providing synchronization at the bit level, clock controls both sender and receiver. Another function is bit rate control. The number of bits sent per second is known as transmission rate, and that is defined by the physical layer. Another function of physical layer is physical topology. Physical layer manages the network topology, in which all devices and networking elements are arranged in a network. As we know, bus topology, star topology, or we can say mesh topology. These are the topology which is managed by the physical layer. Another function is transmission mode. Physical layer is also responsible for the way in which the data flows between two connected devices. This layer manages various transmission modes as possible in the network, like simplex, half duplex and full duplex. Some of the networking devices which work on the physical layer of OSI model are hub, repeater, modem, RJ45 and cables.